This is a video on using calculus to design a barrel. The question states, a 200 cubic meter cylindrical barrel is constructed to minimize its surface area. Find the dimensions of the barrel. So we start by sketching the diagram and finding a formula for the surface area. So here's my cylinder. It consists of the top and bottom, which are circles, and their area is each pi r squared, so I get 2 pi r squared for the two circles. And then the lateral surface area is the length of the top, or 2 pi r, times the height. So there's my formula for the surface area. Next, I can say that the barrel contains 200 cubic meters. That's a volume measurement. And the volume of a cylinder is pi r squared times h. So we can say that pi r squared times h equals 200. The surface area formula has two variables. I'd like one so I could take a derivative. I use the volume formula to solve for h to get rid of the h in the surface area formula. So divide by pi times r squared, and I get h equals 200 over pi r squared, and then substitute it into the surface area formula. And I get the surface area is 2 pi r squared plus 2 pi r times 200 over pi r squared. I can simplify that. The pi's cancel. This r cancels with one of the r's in the r squared, and 2 times 200 is 400. And I get that the surface area equals 2 pi r squared plus 400 over r. I want the minimum surface area. So to find a minimum, I take a derivative and set it equal to 0. The derivative of 2 pi r squared is 4 pi r, and the derivative of 400 over r is negative 400 over r squared. So there's my derivative, and I set that equal to 0 and solve. If I add 400 over r squared to both sides and multiply by r squared, I get that 4 pi r cubed equals 400, and I can solve for r by dividing by 4 pi and taking a cube root, and I put it in my calculator, and I got that r is approximately equal to 3.17. I also want my height because I want the dimensions of the barrel, and the height is 200 over pi r squared, so I plug in, and I get 200 over pi times 3.17 squared, which is about equal to 6.34. So I can conclude that the dimensions for the barrel that will have the minimum surface area is a radius of 3.17 meters and a height of 6.34 meters. And I'm done with the problem.